Thank you. I'm Philomina Mamle Adante Atta from the International Institute for Water and Environmental Engineering, and I'm here to present on the topic application of the Upflow Anaerobic Sludge Blanket Reactor for Wastewater Treatment, the technical, environmental, and socio-economic assessment in developing countries. This presentation has been outlined as follows. I'll look at the introduction, the problem statement, my research objectives, my methodology, and my expected results. Water is a basic necessity for living organisms. As human beings, we depend on water to grow food through agricultural activities. We also use water in the industries, and domestically, we use water to wash, to cook, and to clean. As population increases, water demand and consumption increases, and wastewater generation also increases. But as population increases, water demand and consumption increases, and wastewater generation also increases. This wastewater contains contaminants such as organic matter, it contains nutrients, it contains disease-causing pathogens, heavy metals, and some toxic compounds. Research has shown that in low-income countries, about 90% of the wastewater that is generated is discharged untreated into the environment. Why? Because low-income countries, we lack the adequate infrastructure for wastewater treatment. We also lack the expertise and we lack the finance. As a result of this, wastewater is discharged haphazardly into the environment, and this has led to detrimental effects, such as the pollution of our water bodies. It causes eutrophication and also to the outbreak of diseases. That's the need and the essence for an efficient and economically feasible technology for wastewater treatment in developing countries cannot be undermined. Several wastewater treatment technologies have been designed and implemented over the years. According to Lettinger et al., one technology which is gaining much recognition is the Upflow Anaerobic Sludge Blanket technology. This technology uses anaerobic digestion process, hence the cost of operation is very low. Also with this technology, there's production of biogas, which contains about 60% methane gas. From this methane gas, we can recover electrical energy. This energy can be used to offset the cost of operation or the energy needs of the wastewater treatment plants, thereby reducing the overall cost of treatment. So with the UASV reactor technology, the concept of sanitation financing itself can be actualized. As has been mentioned earlier, wastewater treatment plants are primarily designed to eliminate water pollution and preserve human health. But as the global community moves towards sustainability, sustainable wastewater management will not only ensure that we eliminate water pollution and protect human health, it will also ensure that we minimize the environmental burdens that are associated with wastewater treatment plants and also to recover resources from wastewater. During wastewater treatment systems, we input in chemicals, reagents, we input in energy, and the resulting emissions that come out are in the form of solid emissions, which is the sludge. We have the liquid emissions, which is the effluent water, and gaseous emissions. As the World Health Organization and the various environmental protection agencies keep giving strict guidelines for discharging wastewater into our water bodies, several chemicals, a lot of chemicals and energy are consumed during wastewater treatment processes, and the resulting emissions that come out have also increased in volume. Now, the question we ask ourselves is this sustainable? Technically, is this sustainable? Environmentally, is this sustainable? Socioeconomically, is this sustainable? The amount of resources that we consume, the chemicals, the energy, the electricity, and the emerging emissions that come out. This has been the focus of recent research activities. In the developed countries, several studies have been conducted to assess the sustainability of wastewater treatment systems, but these studies are lacking in the context of developing countries, and especially for the UASV reactor technology, which has proven to be an economically feasible technology which can be implemented in low-income countries. Regarding the UASV reactor technology, there is insufficient knowledge on the numerous advantages that we can explore from the UASV reactor technology. As a result of this, the development and implementation of this technology technology is very minimal in our context, despite its economic feasibility. Also, with the few existing plans that exist, inadequate studies have been conducted to assess the sustainability of these systems. Thus, this research seeks to assess the sustainability of the USB reactor technology in treating wastewater in developing countries. The specific objectives will be to assess the efficiency of the plant in removing pollutants from municipal wastewater. We will also employ the life cycle assessment technique to determine the environmental impacts of the USB technology on the environment. Then lastly, I'll perform a socio-economic assessment to assess the economic implications of this technology in developing countries. This study is a research-based study of the Mudo wastewater treatment plant, which is located in Accra, the capital city of Ghana. According to Ahmed et al. 2018, the Mudo wastewater treatment plant has 3 major treatment units: the USB reactor, which is followed by the trickling filter as post-treatment, and then there's a sedimentation tank, after which the effluent is discharged into the water body. With my objectives, my first methodology is to do the technical assessment. With the technical assessment, I'll look at the plant specification, the plant design specifications, the plant volume, the plant capacity. Then I'll look at the mechanism of operation of the plant. Also, I'll look at the operational conditions, the pH, the temperature, the hydraulic retention time, because research has shown that the operations under which the plant is operated affect the efficiency of the plant. I'll also look at the daily wastewater characteristics, and then I'll look at the plant efficiency in removing parameters of interest. With my second objective, I'll perform the life cycle assessment. According to the International Organization for Standardization, the life cycle assessment is a technique that is used to assess the environmental impact of a product or a process throughout its entire life cycle. According to ISO 14040, the life cycle assessment has 4 phases. We have the goal and scope definition, then we have the inventory phase, then we have the impact assessment phase, and finally the interpretation phase. With the goal and scope definition, there are 3 elements that fall under it. The first one is the reason or the purpose for which we are conducting the LCA. The second element is the system boundary. The system boundary defines the scope of the research, how far we are going with the research, or it demarcates how we are going to do the research. And then the last element under it is the functional unit. The functional unit is defined as a measure that we use to quantify the function of the product system. And with this study, we are going to use 1 cubic meter of wastewater. The second phase under the life cycle is the inventory phase. The inventory phase allows you to identify and quantify all the inputs, which are the resources, the chemicals, the reagents, and the resulting output that comes out, the emissions to air, emissions to water, emissions to land, of all the unit processes that we have defined within the system boundary, and then relate them to the functional units of the system. The third phase is the life cycle impact assessment. With the life cycle impact assessment, it allows you to assess the environmental impact of the environmental burden that we have identified in the inventory phase. So with that one, according to ISO 14040, there are 5 elements. 3 are mandatory and the other 2 are optional. The mandatory elements, we have the selection of the impact categories. The impact categories, these are the environmental issues of concern, such as global warming, such as acidification, such as eutrophication. All these are environmental issues of concern. So we have to select our impact categories which relate to the wastewater treatment plant. Then the second element is the classification. Over here, we will assign each of the inventory parameters to the impact category that they fall under. For instance, if we take carbon dioxide emission, carbon dioxide is a greenhouse gas and it leads to global warming. So we are going to assign carbon dioxide to the impact category of global warming. The next stage is the characterization. Over here, we want to assess the magnitude of each of the inventory parameters which we have assigned within an impact category. The last 2 elements are the normalization and weighting, which according to ISO 14040 are optional. You can choose to do it or you can choose to leave it out. The last phase here is the interpretation. With the interpretation phase, it allows you to identify the significant issues. The significant issues are the hotspots. Then I'll do my cost analysis where I'll look at my capital expenditure and my operational expenditure. Then I'll also do my benefit analysis where I'll look at the resources that I can generate from my wastewater, where I have the effluent, I have the sludge, and I have the biogas from which I can recover resources. I'll also look at my socio-cultural assessment where I'll administer questionnaires to assess how the quality of lives have been improved as a result of the presence of the wastewater treatment plant, and also the public perception and acceptance for using the sludge and also the reclaimed water for agricultural activities. My expected results at the end of my study, I'll be able to establish the performance of the USB reactor in treating municipal wastewater. Then I also identified the environmental hotspots in the Mudo wastewater treatment plants, which requires consideration for improvement. Finally, I can establish the socio-economic impact of the Mudo wastewater treatment plant. Thank you.